This video covers 2.4 evaluating formulas and solving formulas for a variable. Objective 1, evaluating a formula. Objective 1, evaluative formula. A mathematical formula is an equation that describes how two or more variables are related. In example 1, we see a relationship between the Fahrenheit and Celsius temperatures. The relationship between the two is the Fahrenheit temperature is found by taking 9/5 multiplied by whatever the Celsius temperature is, and then adding 32. This is how we would convert any temperature in Celsius over to Fahrenheit. Using 15 degrees for the Celsius temperature, we take 9/5 times 15. 5 goes into 5 one time and into 15 three times. 9 times 3 is 27, and we add 32 to that, giving us 59 degrees Fahrenheit. So a nice cool day out at 59 degrees Fahrenheit. Example 2. This shows us the relationship between the sale price of an item costing P dollars. This formula says that the sale price is always the original price minus the 25% of the price. So that's called your markdown. We reduced the price by 25%. 25% of P is the reduction, and we reduce that from the original price, P. So find the sale price of a pair of jeans that originally cost $40. The original cost is P dollars, so we are going to take an original cost of $40. If we evaluate this equation or formula, when P equals 40, we have 40. Take away 0.25 times 40. If we started off with $40 and we reduced it by 25%, 25% of 40 is $10. So we have reduced this $40 by $10, giving us a sale price of $30. Practice 1 is an increase. The earnings E equals S plus 0.05S is a formula that gives the earnings E of a business if they have sales of S dollars. So they will have sales of S dollars, and they will increase that by 0.05 times S, kind of like a commission, making 5% of the sales. I encourage you to practice this problem. Press pause on your video and come back when you're ready to see the solution worked out. All right, now that you've had a chance to press pause on your video, work this out, I will work this out with you. The earnings of a salesman who had a weekly sales of $12.50, we're going to say that the sales are $12.50. So the earnings are going to be the sales, $12.50, plus 5% of $12.50. When I take $12.50 and multiply by 5, I get an increase of $62.50. If I add that to $12.50, I get $1,312.50. Part B says find the weekly sales. S is the weekly sales. If the earnings are $735. Here we're evaluating the formula for E equals 735. So if E is on the left side of the equation, we take 735 equals S plus 0.05 S. So here we have a decimal equation that contains decimals, and I'd like to clear the decimals. So I multiply everything by 100. Moves everything over 2 spaces, 73500, 100 S plus 5S. The right-hand side is 105S. Equals 73500. 105 times S is 73,500. We divide both sides by 105. And we get S is equal to 73,500 divided by 105. So this time the weekly sales were $700. The next idea is simple interest. The simple interest formula, if an amount of money P called the principal, this is the amount you invest, for a period of T years at an annual interest rate of R expressed as a decimal, 6%, 0.06, 7%, 0.07, the amount of interest earned is given by I equals P times R times T. This is what we call simple interest. So if you invest $5,000 in a 9-month certificate of deposit and you earn 4% simple interest per annum, find the amount of interest Larry's investment will earn. So our principal is $5,000. Our rate is 0.04, but the time is 9 months. And time is in years. 9 months is less than a year, and it's 9 out of the 12 months, which makes this turn into years, or 3/4 of a year. T equals 3/4. Let's make that 3/4 into 0.75, giving us the interest is principal times rate times time. The principal is 5,000. The rate is 0.75. I'm sorry, the time is 0.75. The rate is 0.04, and the time is 0.75. 5,000 times 0.04 is 200. 200 times 0.75 is $150. So Larry made $150 in interest. The next problem is for you to practice. Please press pause on your video and come back when you're ready to see the problem worked out. Now that you've had a chance to work this out, this time our principal is $200. Our 6 months, that's a half of a year, or 0.5. And the interest rate this time is 0.03. So the interest is principal times rate times time, principal of $200, a rate of 0.03, and a time of 0.5. $200 times 0.03 is 6, times 0.5 is 3. So a whopping $3 in interest, but there wasn't that much invested. The next type of formulas we look at is geometry. There's a lot of formulas for geometry. In example 4, we have a circular water feature whose diameter is 4 feet, and it's to be installed in a rectangular garden that's 20 feet by 10 feet. The circular water feature goes somewhere in there, and its diameter is 4 feet. Once we install it, we're going to put some kind of covering, ground covering down on the remaining floor or land. So we want to determine the area to the nearest square foot of the land that's to receive sod. So normally, if the water feature wasn't there, the area of the floor would be length times width, which is 20 times 10, or 200 square feet for the rectangle. But the water feature, we don't put sod under it, so we subtract off the area of the water feature, which is a circle, and its area is pi times the radius squared. If its diameter is 4 feet, then its radius is half of that, 2 feet. So the water feature then has an area of pi times the radius squared, or 4 times pi. If we use 3.14 for pi, 4 times that is going to be 12.56. So the sod then needs to be the area of the rectangle, and we subtract off the water feature because we're not covering it. 200 minus 12.56 is 187.44 square feet. To the nearest square foot, we would round that to 187. But in reality, we would most likely just round it up to about 200 square feet of sod. If sod costs 25 cents per square foot, what will the cost of the lawn be? So the cost of our lawn is going to be the 25 cents times we have 187 of those square feet. That would give us a cost, if we bought 187 square feet of $46.75. The next one talks about pizzas. And this is a practice problem for you to try. I'd like to help you get started. When you have an extra large pizza, it's an 18-inch pizza, which means the diameter is 18 inches. And this one costs $16.99. And a small, which is a 9-inch pizza, half the diameter, costs $8.99, which is the better buy. Now, when I say which is the better buy, I mean if we were feeding about 25 people, would it be cheaper to buy a bunch of extra larges or buy a bunch of smalls? And we all probably know the answer to that because we all go into a pizza restaurant. We know that the extra large is typically a better buy. But let's see, because it's actually a cost per square foot or square inch in this case. So what you want to do is take the cost, $16.99, and divide it by the square inches. Take the cost of $8.99 and divide by its square inches. And since they are circles, you use the formula pi times the radius squared. The labor is pretty intensive on this problem just because of the bad decimals, so I would encourage you to use a calculator. And go ahead and try to come up with the area of those two circles, and then come back when you're ready to see the solution worked out. All right, now that you've had a chance to press pause on your video and work this out, the area of this pizza is going to be pi times its radius squared, and the area of this pizza is going to be pi times its radius squared. Half of 9 is 4.5. So using 3.14 for pi, 9 squared is 81. This area is 254.34 square inches. And the small is 4.5, squared is 20.25, times 3.14, this is roughly around 63.585 square inches. So now we get the cost per square inch. Which one is ever cheaper is going to be the better buy. $16.99 divided by 254.34. This is a cost per square inch of about $0.07 per square inch. And $8.99 divided by 63.585 is a cost of around 14 cents or $0.14 per square inch. So roughly about twice the cost. And that's typically how it goes. So the extra large is a better buy. Its cost per square inch is lower. That's it for 2.4. This concludes 2.4, evaluating formulas and solving formulas for a variable. Objective 1, evaluate a formula.